Look at this. Every star, every planet, every galaxy we can see, all of it, everything humans have ever studied, is less than 5% of the universe. The other 95%, completely invisible, unknown, yet somehow it is controlling the fate of everything. Scientists call this invisible majority dark matter and dark energy. Dark matter pulls. But today, we focus on the stranger, more powerful force, the one that pushes the universe apart. This is the story of dark energy. The greatest mystery in the cosmos. The universe began around 13.8 billion years ago in a hot, dense explosion we call the Big Bang. The evidence is still with us today, a faint afterglow called the cosmic microwave background. Think of it as the baby picture of the universe. It tells us one thing clearly. Space has been expanding ever since. So what is the universe's destiny? For decades, scientists thought there were only two possible outcomes. The Big Crunch. Gravity wins, pulling everything back together in a catastrophic collapse. Or the Big Freeze. Expansion continues forever, but slows down with time. Galaxies drift apart, stars die out, the cosmos coasts into darkness. To decide between these fates, astronomers needed a way to measure vast cosmic distances. They found it in a very special kind of star. They turned to Type 1, a supernovae. These are exploding white dwarf stars that always detonate with the same brightness, like cosmic light bulbs. By comparing how bright they look to how bright they truly are, astronomers can calculate their distance with incredible precision. This cosmic ruler was supposed to show how fast the universe was slowing down. But instead, it revealed something completely unexpected. In the late 1990s, two rival teams set out to measure the universe's slowdown. One team led by Saul Perlmutter, the other by Brian Schmidt and Adam Rice. They studied those distant exploding stars, the Type 1, a supernovae, but the results shocked the world. The supernovae were dimmer than expected, which meant they were farther away than they should have been. The universe was not slowing down, it was accelerating. Imagine tossing a ball into the air. You expect it to slow, stop, and fall. Instead, it speeds up and flies away faster and faster, defying gravity itself. That is what the universe is doing. The expansion of space is accelerating. This discovery was so revolutionary, it earned the 2011 Nobel Prize in Physics. The universe had confessed a secret. Some unknown force was pushing it apart. So what is driving this acceleration? Scientists gave it a name, dark energy, and then began the hunt for an explanation. Suspect 1, Einstein's cosmological constant. Over a century ago, Einstein added a term called lambda to his equations. It acted as a balancing force, holding the universe static. Later, he abandoned it, calling it his biggest blunder. But maybe he was right for the wrong reason. Quantum physics tells us empty space is not truly empty. It seethes with activity, filled with virtual particles, flickering in and out of existence. This vacuum energy could act like repulsive gravity, stretching space apart. But here is the problem. When physicists calculate how strong it should be, the answer is absurd. Their prediction is wrong by 120 orders of magnitude. The worst calculation in the history of science. What does dark energy mean for the ultimate future? If it is constant, we face the Big Freeze. Galaxies drift apart, new stars stop forming. Over trillions of years, the last stars burn out. Cold remnants remain. The universe becomes dark, silent, empty, forever. But if dark energy grows stronger, we face the Big Rip. First, galaxies are torn apart, then solar systems, planets ripped from stars, even atoms themselves shredded, until the very fabric of space-time tears apart. Two possibilities, two endings. Which one is true? Right now, no one knows. That is why dark energy is not just a puzzle, It is the question of how everything ends. Today, the world's most powerful telescopes are searching for answers. The James Webb Space Telescope is looking deeper into cosmic history than ever before. The Vera Rubin Observatory will soon track billions of galaxies to map the universe's growth. And the Euclid mission, launched by the European Space Agency, is dedicated entirely to solving the mystery of dark energy. We are living at the edge of knowledge. Dark energy remains unsolved, a puzzle written into the very fabric of reality. But here is the incredible part. We, right now, are the generation that may discover the truth. Dark energy is not just a mystery, it is the key to understanding the ultimate fate of the universe. So, what do you think dark energy is? A cosmic constant? A new energy field? Or something stranger still? Vote in the poll, share your thoughts in the comments, and subscribe, because this story is still being written.